Okay, grade 12s. Let's have a look at another cubic graph. Let's have a look at this one. Fx is equal to, now watch this, it's negative x cubed. Wow, negative x cubed plus x squared plus 8x minus 12. Okay, now hold on to this. Alright, now what I want to do to sketch it, I'm going to start off with the y-intercept. And as you probably gathered, if x is 0, y will be negative 12. It's the little number at the end here because all the x's go to 0. Now again, the x-intercepts, I think we're going to need to use the smiley face. So 0 is equal to negative x cubed plus x squared plus 8x minus 12, which of course is where y is 0. Now to make life easier, I'm just going to bring the terms to the left on the other side of the equals, and we should have a little bit more of a nicer kind of looking cubic equation to deal with. Now let's try some factors of 12 that could work, and if I do, I'm going to go straight to the one that works. Let's have a look at x equals 2 and see if that works for us. So that's going to give me 2 cubed minus 2 squared minus 8 times 2 plus 12. So what does that give us? 8 minus 4 minus 16 plus 12. Well, that's 4 minus 16 is negative 12 plus 12 is of course 0. So what do we have there? We've got a little factor here, which is x minus 2 equals 0 is our factor. Great. Now we can solve the cubic. So let's go back to our cubic equation. X cubed minus x squared minus 8x plus 12. And we put our little factor there. So it's x minus 2. And then we say x cubed over x is x squared. We've got a missing term. 12 over negative 2 is negative 6. Let's just test that. X cubed 12. Okay, times out. And then we do the smiley face, which is negative 2x squared plus mx squared is equal to negative 1x squared. That's the coefficient of x squared is minus 1. So we can keep it there, and we equate these terms. So divide throughout by the x squared, and what do we have? So minus 2 plus m is minus 1, so m is equal to negative 1 plus 2, which is 1. So our cubic equation is x minus 2, x squared plus mx, which is 1, minus 6. And here we go. So what's that? That's x minus 2, x plus 3, and another repeated bracket there. So we've got a repeated x-intercept. That's probably where where turning point will be, or x is equal to negative 3. Okay, now how do we get the turning points? Now go back to the original. It's very important that you focus on the original. Now this is going to get a bit interesting here. Okay, now so there's our original. Let's get the derivative. So what would that give us there? Negative 3x squared. Okay, bring down the 2 and subtract 1. The derivative of 8x is 8, and negative 12 is 0. At a turning point, your derivative is of course 0. No common factors, but we can bring everybody to the left. Okay, let's factorize this little guy. So it gives me 3x plus 4, I think it is, and then x minus 2. Let's just check that. 3x squared minus 8, 4x minus 6x is negative 2. So we have here 3x is equal to negative 4, x is negative 4 over 3. That's a horrible turning point x value, or x equals 2. Now notice x equals 2 as a turning point corresponds with this x-intercept, and that's where the graph turns on the x-axis. Okay, and all we do is work out the corresponding y values in the original. So let's go f of negative 4/3. Let's handle the difficult fraction first. So what is the original? Let's go up and check there. There's the original. So let's plug in there. That's going to give me negative x cubed. So we plug that in there. And I'm going to probably use a calculator to help me. This is awkward. Plus negative x all squared plus 8 times negative 4/3, and then we've got minus 12. Now, if you put this whole mess into the calculator, it comes to some horrific fraction. Okay, but don't worry about it. It doesn't have to be perfectly drawn to scale. So the one turning point that we have is this horrible one here, which is minus 4/3 minus 1 and a third if you like, and then negative 500 over 27, which is rather unpleasant. Okay, but nevertheless seems to be fine. Okay. Alright, so what else do we know? Once we've got our turning points, what would be the f of 2? Well, I think that we've already worked out as naught. So there's your other turning point. We already worked it out as naught. Okay, from the factor theorem at the top here when we were testing values there, you see, we looked at x equals 2 and it actually works. Good. Alright, so that's where the turning points are. Okay, the other thing is we'll do the points of inflection as well. So if f prime x is equal to negative 3x squared plus 2x plus 8, well, if we differentiate again, we will get negative 6x plus 2. So if you put that equal to naught, let's see where the points of inflection will be. So bring that to the left. And then we've got x is equal to 2 over 6, which is 1/3. And then if we work out the f of 1/3, if we want the coordinates of the point of inflection, the y value, let's go to the original minus x cubed. Let's make it cubed. Okay, it's cubed. Plus 1/3 squared plus 8 times a third. Subtract 12. And if you use a calculator, and you try and work that mess out, which is rather unpleasant, you're going to land up getting an answer of minus 250 over 27. Very fractiony this, but you can get it. So your points of inflection would be 1/3 and negative 250 over 27. Not nice. But we can now proceed to draw this graph. Now let's see what this looks like. Okay, there we go. Let's have a set of axes, and what we can do is we can put the x-intercept there. Now I don't have to do it perfectly. I've got negative 3 naught there. That's the one x-intercept. Go back and check. There we go. If we go back, the one x-intercept was going to be at negative 3. Where was it there? There we go. There it is, negative 3. And 2 is where it's repeating itself. Okay, so it's going to repeat itself at 2 there. There's a turning point there. Now remember, the shape is also, it goes down like this. Okay, because of that, because it was negative x cubed, you see, and that is negative, so it goes like this. So in other words, it's definitely going to be turning here. Where was the other turning point? Now the other turning point was a horrible one. It was minus, let's go see, this is minus 1 and a third here. Okay, so it's going to be at, not quite there, minus 1 and a third, and somewhere down here. It doesn't have to be perfectly accurate, so we can put our one turning point there, our minimum there, which is about right. And then we've got the y-intercept is 0, negative 12. And there we go. So it's going to come down. And what's your points of inflection? Well, we'll do that in a moment. We'll just quickly see that the points of inflection is 1/3 minus 250 over 27. Okay, so it'll go 1/3 down to about there. Okay, 1/3 minus 250 over 27, which is approximately there. So this graph comes down. It goes to its turning point, comes up, cuts the y-axis, and eventually turns at its points of inflection, or it goes through the points of inflection, changes its shape, turns at 2/0, and all the way down we go. That's a very dreadful graph with all the fractions, but it's important to know this. There's your points of inflection, y-intercept, x-intercept, and your turning points there. Okay, and there's your graph. Okay, when you deal with this, with these cubics.